Let's look at scatterplot, correlation, and regression. Sometimes there's very little relationship between two numerical variables, x and y. For example, let x equal height and y equal the number of compact discs owned. There's no relationship between those two. Or how about let x equal grade point average and y equal lung capacity. Again, no relationship between the two. But sometimes there is a strong relationship between two numerical variables, x and y. For example, let x equal height and y equal arm span. As the height of a person goes up, the arm span tends to go up as well. Let x equal the weight of a car and y equal the gas mileage. As the weight of a car goes up, the gas mileage tends to go down. Again, there's a strong relationship between the two numerical variables. When there is a strong relationship, you can predict one variable if you know the value of the other variable. If you know x, you can predict y, and vice versa. For example, can you predict the arm span of an NBA player based on his height? Here are the heights and arm spans of 30 NBA prospects in the upcoming draft. Okay, let's produce a scatter plot of these data. So here's what a scatter plot looks like. So let height be the x-coordinate and let arm span be the y-coordinate. We plot the resulting points. So here's what we go about doing. We just come up with a plot like this. Let's say this is 80, 182, 83, 84, 85. And same thing on the y-axis. Let's say that's 80, 81, 82, 83, 84, 85 there. That's 86, 87, a little higher. So for example, that first point, 82.5, 87, it's about 82.5, 87 is going to be right there. The second point, the x-coordinate is 82, that's the height, and the y-coordinate is 87, that's the arm span. So 82, 87 would be about there. Next one, height is 80, arm span is 87, so that'd be about over there. Next one, the height is 80 and the arm span is 84. So again, the y-coordinate is 80 and the x-coordinate is 84. I'm sorry, the x-coordinate is 80 and the y-coordinate is 84. So the point 80, 84 would be about over there. Okay, so this is what a scatter plot looks like. You'd plot the points 82.5, 87, 82, 87, 80, 87, etc. Let's look at how to do this on the TI. First, let's enter the data into the TI. And here's how we'd go about doing this. So we press Stat and then choose Edit. Well, first let's turn this thing on. Let me show you how to get to this page. So you press Stat, and then under Stat, choose Edit. So let's do Enter. Okay, so we type the entries from the first column and press Enter after each. So for example, the first data point, first height was 82.5, so it's 82.5, and then Enter. The next height was 82, so we've got 82, and then Enter. The next height was 80, and then Enter. Next height was 80 as well, and then Enter. Now notice we're not entering any of the arm spans. Those will come later. Blah, 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 blah. And we just continue this. I didn't want to bore you by entering all the data in front of you. There's nothing more boring than watching a teacher enter data. Okay, so I've entered all those in the in that first column, L1. Those are all the heights. Now, to get to the second column, press the right arrow. Now we're in the second column. And now let's type in the second column entries. That would be 87, 87, 87. So we've got 87. That's our first arm span. We've got another guy with an arm span of 87. Then we got another guy with an arm span of 87. Then we got a guy with an arm span of 84. And we just keep on entering these. Blah, 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 blah. Okay, so now I've entered all the data into that second column. And now we press Quit. Okay, so we get back to the home screen. We can press Clear. We don't need to, though. Okay, so now let me show you how we display the scatter plot. We press Stat Plot, choose Plot, and then On. Choose those little dots as the type of graph. X-list and Y-list should be followed by L1 and L2 respectively. L1's the X-coordinates, L2's the Y-coordinates. That little dots is the mark. We press Quit, and then Zoom and 9 Zoom Stat. Oh my goodness, there's no way you're going to remember that. So let me just show you what that looks like on the TI. Okay, so we press Stat Plot. Let's see, we've got Stat Plot, so that's second, and then Y equals. We press Enter. Then we choose Plot. Actually, yeah, we choose, I'm sorry, I say plot, but really we want to choose plot 1 on there. So sorry about that. That should say plot 1 and not plot. Okay, now we choose on. That's great. We've chosen on. This should be our graph. That's what it should look like. Let's see. X list is L1, Y list is L2. That's great. If you need to change those, the L1 and L2 and all the other ones are above these keys. And choose that little dot as the mark. If, for example, you wanted to choose another dot as the mark, I don't know why you'd want to, but you could just use the arrow keys and then press Enter to navigate. We don't want that, though. We're just going to press that. We're just going to keep that. Okay, and then having entered all of those, we quit. And then we press Zoom and choose Zoom Stat. So under Zoom, yeah, so let's press Zoom. Whoops. So we press Zoom, and then 9 is Zoom Stat. So you can even just type 9 if you want to. Or we could just scroll down and then enter. And there we are. That's our scatter plot. That's much better than the little dots that we had earlier. Okay, now let's find the line which best fits the data, the least squares regression line. So again, if you wanted to, you want to plot these data. Okay, the least squares regression line is the line which best fits the data. I'd say the least squares regression line is going to be something like that. So, yeah, it's going to be something like, I'd say it's something like this over here. It's hard to tell exactly. Okay. So here's how we get the least squares regression line. Look under Catalog, under Catalog, and choose Diagnostic On and press Enter. So Catalog is second and then 0. So second, 0, that's Catalog, and then scroll down to Diagnostic On. Just time to tell a joke. Wish I had a good one. Sorry. Diagnostic On. There we are. Okay, and then we press Enter. Okay, this is going to print out a statistic called the correlation coefficient when we calculate the equation of the least squares regression line. And if we do this today, we'll never have to do it again, unless, of course, we change the batteries. Then we'd have to do it. But you only need to do it once. You don't need to do this Diagnostic On thing, every time you want to work with the calculator. Okay. So now, here's how we're going to enter the least squares regression line. So press Stat. Let's see. So we've got Stat. And then under Calc, so we need to go to Calc, choose 4, and that's least linear regression AX plus B. And so it's going to print it on your home screen. Now on the same line after it, type a Y1. This is a little tricky, but here's how we type a Y1. So what we do is we press vars. Here's vars. And then yvars. And then function. So we need to choose function 1. And then Y1 enter. Okay, so that's the way you get a Y1 after the linear regression. Now you press enter, and you get the equation of the least squares regression line, AX plus B. So Y equals AX plus B, where A is about 1.1, B is about -4. And you could actually plug that in for A and B, and that's the equation of the line. Now this is really cool. If you press Y equals, you'll see that the least squares regression line, that line that best fits the data, is automatically entered as Y1. And that's why we bothered to type Y1 after, linear regression AX plus B. Okay, so now to graph the scatter plot and the least squares regression line, press Zoom and then choose 9, Zoom Stat. Okay, so what we want is Zoom. Yeah, let's quit. So what we're going to do is we're going to quit. Sorry, you got to quit first. Okay, and then do Zoom, and then 9 is Zoom Stat. I'm just going to press 9. That'll do it. There it is. Isn't that cool? So that plots your least squares regression line. And that was pretty close to what we had estimated earlier. So that's the line that best fits the data. Now, so here's the question we asked originally. How well can you predict the arm span of an NBA player based on his height? The correlation coefficient is a number between -1 and 1, which tells us whether y tends to increase or tends to decrease as x increases. We use r to represent the sample correlation, and we use the Greek letter rho to represent the population correlation. Recall that a population includes everyone, and a sample includes just some. Okay, so for example, r equals 1 would be a perfect linear relationship. As x increases, y tends to increase. R equals -1 would be a perfect linear relationship. As x increases, y tends to decrease. And r equals 0 means there's no linear relationship. As x increases, we cannot say that y tends to increase or decrease. Okay, so here's how we find the correlation. We press quit to get back to the home screen. Let's see, so second and then mode will get us to quit. And now you'll get the equation least squares regression line. We saw that earlier, as well as the correlation coefficient. Notice the correlation is 0.849. That's a really good correlation. Anything that's that close to 1 is pretty good. So the closer it is to 1 or -1, then the stronger the correlation, and the better we can predict the arm span of an NBA player based on his height. So for example, let's predict the arm span of Michael Jordan. You got to check this out. I love this highlight. Whoops. Let's play this highlight.